Let's talk about the dot product. Find the length of the vector 3, 4. Well, by the Pythagorean theorem, the length of 3, 4 is going to be the square root of 3 squared plus 4 squared. In other words, the square root of 9 plus 16, square root of 25, which is 5. In general, the length of the vector a, namely a1, a2, is going to be the square root of a1 squared plus a2 squared, and again, that's by the Pythagorean theorem. We denote this by this symbol. Now, some books use this symbol instead. This is called the norm of a, or the magnitude of a. I'm not going to use this symbol because that's too confusing. It looks like the absolute value of a. I don't want that. Similarly, the length of a three-dimensional vector, norm of a three-dimensional vector, magnitude of a three-dimensional vector is going to be the square root of a1 squared plus a2 squared plus a3 squared. True or false, if k is a scalar, then the length of ka always equals k times the length of a. Oh, that word always is a dead giveaway. This is false if k is negative. However, the length of ka always equals the absolute value of k times the length of a. Sometimes software will give answers in terms of unit vectors, which are vectors of length 1. The unit vector in the direction of a is a divided by the length of a. So, for example, find the unit vector in the direction of 3, 4. The unit vector in the direction of 3, 4, that's a vector of length 1 in the direction of 3, 4. It's just going to be 3, 4 divided by the length of 3, 4, which is 3, 4 divided by 5, or in other words, 3/5, 4/5. Same direction as 3, 4, just has length 1. Some unit vectors we work with frequently are standard unit vectors. In R2, the standard unit vectors are I equals 1, 0, and j equals 0, 1. We can express any vector in terms of these standard unit vectors. For example, express 3, 4 in terms of standard unit vectors. Oh, that's just 3 times 1, 0 plus 4 times 0, 1. In other words, 3i plus 4j. In R3, the standard unit vectors are I equals 1, 0, 0, j equals 0, 1, 0, and k equals 0, 0, 1. So express 1, 2, 3 in terms of standard unit vectors. That's just going to be I plus 2j plus 3k. In Rn, the standard unit vectors are E1 equals 1, 0, 0, 0, 0, E2 equals 0, 1, 0, 0, 0, and E sub n equals 0, 0, 0, 1. There are different products involving vectors. The dot product or inner product of A equals A1, A2, A3, and B equals B1, B2, B3 is A dot B. That's why we call it a dot product. That's going to be A1, B1 plus A2, B2 plus A3, B3. So notice we're multiplying these component-wise. We use it to find the angle between the two vectors. For example, find the dot product of A equals 1, 2 and B equals 3, 4. Oh, that's just going to be 1 times 3, which is 1, 3, plus 2 times 4. In other words, 3 plus 8, or 11. Here's some dot product laws. A dot B equals B dot A, commutativity. A dot B plus C equals A dot B plus A dot C. That's the distributive principle, distributive property. If k is a scalar, ka dot b equals k times a dot b, and that's going to be the same thing as a dot kb. A dot, oh, this one's handy. A dot b equals the length of a, length of b cosine theta, where theta is the angle between a and b. We're going to use that over and over again. A dot b equals 0 if and only if a and b are orthogonal, in other words, perpendicular, and that follows from the previous principle because a dot b equals 0 only if the cosine of theta is 0, which is true if the angle between a and b is 90 degrees or 270. A dot a equals length of a squared, and a and b are orthogonal, perpendicular, normal, if and only if the length of a plus b squared equals the length of a squared plus the length of b squared. Oh, that's just the Pythagorean theorem. So for example, let's find the angle between a equals 1, 2 and b equals 3, 4. We'll use this principle. A dot b equals the length of a, length of b cosine theta. Theta is the angle between a and b. 1, 2 dot 3, 4 equals the length of 1, 2 times the length of 3, 4 times the cosine of theta. Okay, so length of 1, 2 dot 3, 4, we've seen that before. That's 1 times 3 plus 2 times 4. The length of 1, 2 That's just going to be square root of 1 squared plus 2 squared, length of 3, 4. That's just the square root of 3 squared plus 4 squared, cosine theta. So let's evaluate this. So this is going to be 3 plus 8. And as for this, well, that'll be square root of 5 times square root of 25 times cosine theta. So in other words, we have 11 equals the square root of 5 times the square root of 25 times cosine theta, or in other words, 11 over 5 root 5 equals cosine theta. And that's because the square root of 25 is 5. So 11 over 5 root 5 is cosine theta. Theta is the inverse cosine of 11 over 5 root 5, and that angle is 10 degrees. In an orthonormal set, the vectors are all perpendicular to each other. Give an example of an orthonormal set? Well, how about 1, 0, 0, 1, or 1, 0, 0, 1, 0, 0, 0, 0?